It's a simple problem that we're going to look at now. It's a plate with a hole. I'm going to take a plain stress problem kind of a situation and I've already set the preferences to structural and go to element type, add, edit. I'm going to add a solid element. Right now I'm going to just go with a quad 4 node element. I don't need any other options, and I don't think there is any real settings that you need to do. I don't think there is any. Yep, there is not. Set the material properties, go to material properties, material models, structural, linear, elastic, isotropic, and set it in 70E3, reminding you that ANSYS does not have any system of units, and I can basically use any consistent set of units that I need, and just make sure that you're going to interpret the results in the right units that you have set in the beginning. So I'm going to use the values of Newton per millimeter squared or megapascals. The Young's modulus is 70 megapascals. I'm very sorry, 70 gigapascals, and hence I am writing 70E3. You can as well write 70,000 or 70E3. E3 basically means Newton raised to 3 GPa. So what this value is basically, it's basically 7,000 megapascals, which is nothing but 70 gigapascals, and 1 megapascal is 1 Newton per millimeter squared. Basically my units is thus in newtons and millimeters. And the Poisson's ratio for aluminum, I'm going to make it as 0.33. I don't need anything else. I don't think anything else because it's basically a static model analysis that I'm going to be doing. I don't need sections modeling. Oh yes, I need to create a modeling. First create a area. First I need to create a rectangle. I can either choose by two corners or by center or corner. You notice a small arrow mark here, which basically represents that you need to pick by graphically choose the points that you need, which is not always recommended. I would recommend you to go ahead with by dimensions if you need exact values, but for the ease of sake, if you are using a GUI method, you could as well go for the first two options in a you go to by dimensions. I have a starting point, the bottom left corner at 0 and 0, and the top right corner is going to be at 100 millimeters and along the length, and say around 40 millimeters along the height. Okay, now I got the rectangle that I needed. This is going to be 0 0, and that is going to be 100, 40. All I need to create is create a circle at the center. First choose the values of the center of the circle, which is 0 and 0, and the radius of the circle, let me see, probably about 5 would be too large, I guess. I'll give around 2.5, I guess. Okay, that's nice. Okay, we did a mistake, so we created the circle at this place, which is not entirely that we needed, so go ahead and delete that. Where is delete? Okay, so I need to be deleting areas and below, because area is at the third level. Below that you have the line, and below that you have the key point, so all of them need to be deleted along with the instance of the area that I need. Select it off, and thus goes the area. So create the circle once again with the new center. Since the length is 100, I need it to be at midway along the length, and also midway along the breadth, which is height, which is 20 right now, and I needed the radius to be at 2.5. okay, let me go ahead and show you a Boolean operation. Now you have something like create. Now we have already created what you wanted, some stuff, and now I'm going to be doing is basically operate. Before I do some operations, I want to show you how to optimize the mesh once I finish all these stuffs. Let me go ahead and write lplot, which basically is line plotting. I could go ahead and create another domain here, right? So let me show you now. Create a line by straight line starting here and here. Okay, which would not be entirely recommended, of course. Yeah, and one here till there, if I am able to create something like that, then, or from here to here, here to here, here to here. which of course is a pathetic mesh. It's not going to be good. I'm going to be going ahead and deleting this off because I have a triangle here. Obviously, since it's a triangle, it's going to be not able to completely sweep mesh, because you can't sweep from one place to another without having to lose the complete structured mesh. So I'm going to delete it off. I don't need these lines anymore. Lines and below, select all those lines and click OK. Now we are back to the original geometry. Click replot. So what am I going to do with a model like this? Okay, not bad. So let's create a rectangle here. We'll create a rectangle such that it will be easier for us to connect the edges, right? Or even better, you could go ahead and create a small square around that. Let me create something like a square. Or before that, go to areas and rectangle, and by dimensions. Here you need to be very careful of choosing the values. I'm going to just do it mentally here. You could take it off on a piece of paper and then do it as well. So if I need a square of, say, length 10 millimeters, I'm not gonna, okay, what's the radius of the circle that I have? It's 2.5. so the diameter is going to be, radius is 2.5, the diameter is going to be 5 millimeters. I need approximately from this side to this side. That means to say that say the length of this is going to be 20 millimeters offset across the center. So this is 2.5. I'm going to make this as say 6 millimeters towards the left and 6 millimeters towards the right, and the original center that I have is at 50. So the left bottom corner is going to be at -6, and okay, and the right bottom and the right top corner is going to be the 50 plus 6. Fine, and I need it to be a square in this particular case, or let me choose a rectangle instead of a square of, say, length 12 millimeters, which I have already included in the values of x1 and x2. And in this case, now I'm going to be going ahead and giving a height of how much, say 8 millimeters. So it got to be 20 is the center or the midway along the height. So the bottom left corner is going to be 20 minus 4, because the height of this new rectangle that I need is 4. So this is going to be 20 plus 4. Okay, so there you have it. I have the rectangle. I'll just go and I'll plot it. Now this is a rectangle that I needed. It's not actually quite exactly what I needed, because the aspect ratio is not quite exact. It's going to give a not a very good mesh when I do the finishing touches. So let me go ahead and then choose a proper mesh for this particular thing. Go ahead and delete this areas and below. Okay, previous. Oops, yes, this is the one that I do not need. Go to create, and areas, once again by dimensions. All I need to do is change this particular thing, maybe to 5 perhaps, and this 5 perhaps. Okay. Now this seems a bit okay, not bad. Okay, now I just need to go ahead and create a line, perhaps a line. Okay. Let's choose to do like this. Create a line, straight line from here to here, and from here to here, from here to here, and here to here, right? Fine. So now this is going to be one module, and another region, and another region, another region. There's another way of doing the mesh. I'm going to show it to you shortly. Now once this is done, I'm going to be proceeding further, and let me delete the original volume that I had, because it's not going to be of any use anymore to me. Areas only, because I still need to retain the other edges. Let me go ahead and write an L plot. Now if you see, if I make an L plot, area plot, now you see only what is visible is the inner rectangle and the circle. But however, when I write the L plot, the original lines are still existing. However, the area of the original rectangle has now been deleted, right? So only the parent has been deleted, not the child. The child are still there, the child being the line and the points. Okay, now I just need to create an area. Go to create areas, arbitrary by through points, through key points. 1 ton 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 ton. One area is done. Ton ton ton. Second area is done. And ton ton. Third area is done. Again, proceed and do the same thing here. This area is also done. Okay, now all I need to do is go ahead and say perhaps delete the inner ones as well, areas only, and this one also I'm going to delete, and this one is also I'm going to be deleted off. So when I write the a plot, now is all that is visible. However, when I write the l plot, which is display line options, I still have the inner rectangle and inner circle. So what I need to basically do now is I just need to develop some kind of a point here, and a point here, and a point here, and a point here, right? So that's not very, it's not complicated or anything. It's not overly complicated. All I need to do is create a line. Let me see what options are there to create a line, right? Normal to line. Okay, normal to two lines. So one point is this and another point is this. Obviously it cannot be done. Cancel it off. So now I'm going to be having okay, at angle to line, straight line at angle to line. No, okay, cancel this off. What do I need to make here? Okay, not overly complicated or anything. Or before that, I just need to stitch them both up, or I can as well go ahead and create an active coordinate system. Don't give any name to this particular key point. I need to select a key point at this point so that I can connect them up like that. Okay, so I know that the center of this circle is basically 50 and 20, so I just need to offset the points that I need to create it. And I know that the radius of the circle is 2.5. That means that this one point is going to be 2.5 here, and then that also is going to be 2.5. So I've created one circle. Okay, oops, okay, I understood. So this is going to be 2.5 into cos of say 45 into 3.1459 just by 180. Let me check if what I've written the expression is proper here, because I'm not able to see it properly. Okay, so here it is. And the second point is gonna be, this is gonna be sine in this place. So take this off like this from here and paste it off here, and this is gonna be coming, oops, this has to be 20 plus this, apply. Now it's exactly at the point where I need it. Okay, now I need to create a point on the green line as well, which is going to be nothing but just minus here, and not a big deal. And I need another on the yellow line there, which is going to be minus again, and plus here would give me this point. Okay, now go and create lines, straight line from here to here, again from there to there, here to here, here to there. Fine. Now we need to proceed further and go and operate this particular thing here. Go to Booleans and say divide line by point. I don't see that. Okay, line with options. Oh, I could have done it easily. Okay, line with options. Okay, that's not okay. Ratio, it's apply. Okay, I divided it up. Apply. Okay, I could have actually avoided calculation of all these points because I have a better method. All I need to do now is just add them up, right? Add this line and this line, apply. Do the same stuff again and again and again. So I have basically created some areas that I needed, and some lines or the boundaries of the areas that I needed. Now all I need to create is an arbitrary area, arbitrary lines area by line. So select this one, this one, this one, this one, this one. Okay, is referenced by only one improperly connected line for the new segment. Okay, proceed. Okay, plot. Let's go to plot controls, numberings. So now we see that there is okay, it's interesting. Go to plot. Okay, you can see that there seems to be an overlapping point here which needs to be just taken off. Go to delete key points. Okay, okay, let's try another thing. Areas arbitrary by lines. Okay, not bad. Plot. Now let's try to operate this. Operate. Understood. It's a simple thing. So delete areas only. Previous one, I don't need this. So what I'm going to do now is create this polygon and then subtract the circle out of it. Okay, create areas. I'm going to show you a better method of doing all these things. I'm just showing you one method, right? Through key points. Let me show it to you for one thing. Oh, okay, that's fantastic. So if I delete this up, plot controls, go to numbering, and if I turn on the area numbers as well, so it's already been provided. Done. Okay, through key points, one this, and this. Okay, that needs to be removed now. So how do we do that? Go to operate, booleans, subtract areas. This is the one and that's the one. Okay, now we've created one thing. Not necessary. Go to create areas arbitrary through key points once again, and I'm going to select these points and create circle ends again, which needs to be at 50 and 20 and radius 2.5. Okay, now that we have created, now I need to operate them. Subtract areas, select this and select that. Now it's done again. Now again create areas arbitrary through key points. Okay, I select this and this and this. Okay, create a circle, solid circle, 50, 20, 2.5. Go to operate, Boolean, subtract areas, this one. Okay, so now we have created our part of the modeling, and I'm just going to switch off all these key point numbers and stuff so that it looks a bit simpler, and go to L plot. Now we have a neat looking structure which we can structural make a solid mesh, like, okay. And then now what I'm going to do, booleans, let me see if I can do this. Yep, go to plot controls, numbering, and let me just click down on the line numbers. I see the line numbers are proper, none of them are intersecting or overlapping each other. Now that means that our modeling is proper. Go back. We'll go to meshing and mesh tool and set the lines, this, that, this and this one and this one. All of them are going to have, say, I need 8 ones, right? Maybe I did a mistake. Clear, pick all, set this. Element edge length, I should have put it in the number of divisions. Okay, now I have something which is looking sane. Now all I need to do is set these up. Basically go for 20. I'm going to show you something which is very interesting here. I'm going to make, perhaps, say 20 would be a bit too high, I guess 15, and say I give something like 0.5 for the spacing ratio. Okay, so now what do I need to do? I need to flip them. Flip this. That's proper. That's proper as well. This needs to be flipped. So now we're done with this, and we need to do the same kind of stuff for this now. Now you can see that there is a small ambiguity which we can clear it off. Okay, I'm going to do it and then show it to you. Set these stuffs and say I'm gonna do, I can see here visually the 1 2 3 4 5 6 7 800 by 100 is the length of this structure. 100 by 8 is gonna give me how much? 12.5. So 12.5 is the average element length. So you like 12.5 with a more stricter value. Okay. still seems pathetic, right? So I'll just clear them, set these up once again. Say probably 7.5. which there needs some flipping to be done. Yep. Let's go ahead and try to mesh these things. Put them mapped. Now we've mapped these. That's done. That's done. That's done as well. So in essence, what you basically see here is we have created a mapped mesh. Maybe something is wrong here. I guess you have got the methods by this time. I'm going to do the same thing and show it across to you, and how to do a better mesh for this particular geometry in the next video.